I'll move to the next presentation. This is also coming from a manufacturer, SolarSpace, which is a leading cell supplier that has also expanded into the module business. We have Jeremy, who is director at SolarSpace. He's going to talk about the characteristics of bifacial TOPCon cells from SolarSpace. Jeremy, the floor is yours.
Yeah, hi, thank you. Thank you for the introduction. Nice to meet you. Sorry, looks camera a little bit dark. Can you see me?
Yeah, it's a little dark, but I think it's okay.
Good. Okay. So, hello everyone, this is Jeremy from SolarSpace. And my presentation today is about characteristics of the bifacial TOPCon cells. So today I will talk about first about the sales roadmap, and then we'll discuss about the sales characteristics in terms of the wafer size, electrical performance, and also about how the cell can impact on the solar panels. So as you may already well know that the solar cells efficiency has been increased, keeping be increasing, and like SolarSpace starts to do the sales from 2010, and the time the sales efficiency only 16, and now we are producing 210 TOPCon cells, and the efficiency can reach more than 25%. And during this process, we can see the cells technologies and also the wafer size has been changed. Like the wafer size has been changed from smaller to bigger to currently 210, and the cell technology has been switched from like a P-type wafer with PERC process to currently N-type wafer with the TOPCon process. Let's talk about the wafer size. So generally speaking, currently on the market, the three mainstream wafers, these three sizes. One is the 184, or a little bit larger than 184, but we call this one in one same theory. For this kind of wafer, the purpose of the wafer is slightly little bigger than 182 is to make sure that in the same module size, the power output can become higher. Like it will improve 5 watts if you are using a bigger wafer in the 182 theory. And also the second one, you can see the rectangular wafer. You know, the rectangular wafer, it was designed in response to the standardized module size that was agreed among the several tier 1 module suppliers in China. They agreed that this size of module can provide the design to standardize this size dimension so that this can best improve the shipment and also the installation cost in the field. So for the third one is now currently the biggest wafer available in the market that can help the module to reach the 700 watt plus. Talking about the electrical performance, we know that TOPCon modules have higher power output than the PERC modules, from 20 to 30 watt. And also TOPCon module has lower temperature coefficient and also have higher bifaciality. And also on the warranty side, the TOPCon module has less power power degradation. On the cells level, because the TOPCon cells have more processes, this is like based on the PERC process, they have more processes to improve the efficiency and to improve the VOC of the cell. So that's why from the cell level, we can see the cell has better VOC, and this will, improve the module power, the performance and under low light condition. And also in the cell level, this process will help to bring lower temperature coefficient and higher bifaciality due to the N-type wafer used. Then we talk about the solar powers, how the cell can impact on the solar powers and solar modules output power. For the PV module power, when it is determined by the cell's performance, and also of course the number of cells to be used on the same module. Talking about the cell performance, there are some electrical parameters that matter to for the power output, and also the consumption of the silver paste. Let's say in the cell process, we call it the wet weight of the silver paste, and this can determine the solderability when the cells are connected to form a module. Based on our study, that from the cells level, the lower serial resistance and also higher shrink resistance can help bring higher power output for the final panel's power output. In terms of the solar panels color, the color of the solar panels can be impacted by several factors such as the glass and the EVA, and also the original color of the cell. Talking about the cell, when the cell's color is actually related to the reflectivity from the cell surface. It means when the reflectivity is higher, then the cells will seem to be brighter. And the cell reflectivity is related to the profile, the wafer surface, and this surface is formed after the texturing process. Based on our experimental study, we seeing from this curve, when there is like a big profile, then we can see the reflectivity will be higher. So this will decide the final color of the cell. Also, the cell reflectivity is related to the nitride films properties such as reflectivity also, and we can see with different the nitride reflectivity, then there is different reflectivity from the cell surface. Now we will focus on talking about how the cell can impact on the panel's reliability. So for the hotspot issue, I think everyone knows that hotspot issue is a very common issue in the field, which can greatly impact the generation of the whole solar system. And after study of this hotspot issue, we can see there may be a lot of factors that are related to talking about the cells level. We identified there are some defects may be related to the hotspot, like the dark spots per etching and the cell crack and the pollution. So to mitigate the issue, from the sales level, the improvement can be good cell binning method according to the the parameters we mentioned before, like the dark current and also the shrink resistance, and also a well-designed year and visual criteria, and also can help to prevent this kind of defect cells from being shipped into a multi-factory to be fabricated. About the PID issue, from the sales level, what we can do is to control the nitrile layers reflectivity. This is one thing. It means when there is higher reflectivity, then the cell is more resistant to the PID issue. And also a good control of the front surface oxidation of the cell is also very important, because in the cell process, now every factory should have already include this oxidation process to get a PID-free cell. But the problem is that if this process is robust or enough or not, because there's no 100% inspection on each wafer to inspect the quality of this oxidation film. So it will be very important during cell process to pay attention to the oxidation of the surface of the wafer. The third issue is about the zero bus corrosion. And this is related to the civil paste used and the recipe you are using during the cell plating process. And for the reliability issue like TC and DH, the cell corrosion matters a lot. It can be related with 3 failure modes. Sometimes we can see the corrosion start from the cell edge, and also can be from the cell ribbon and from the cell center. So in this sense, to have a good quality of cell can help to relieve the reliability issues on the module level. Okay, so I will just want to give a quick show to our company's overview. Like SolarSpace was top 3 sales shipment producer this year, and we are just started to produce modules, and we are also list and tier 1 module supplier, and actually we are supplying cells to all the tier 1 module suppliers, and also for the multi-business, we are doing OEM for these tier 1 suppliers, and also have our own brand with tier 1 list. Our panels cover most of the common, the panel types that's available in the market, including M10 cells panels for all scenarios, and also G12 big panels, which can reach the power output higher than 700 watts. And also we have full black, TOPCon panels, which is good for the rooftop use. Oh, this is all my presentation today. Thank you.
Okay, thank you very much, Jeremy. So, you mentioned several characterization methods to figure out what is right cell and what are the problems that could arise from cell that can at the end lead to questions on the module reliability. So are you also taking all these parameters into consideration when you are sorting your cells?
Yeah, this is a good question. So that's why it's like how we works. we actually start to produce modules at a very early. So when we are doing, there was a process during cell, after cell flash, there was a cell binning process. So in this process, we can design the recipe to sort the cells, by the ISH or by the I-reverse and by the efficiency. Maybe most of the cell suppliers focus on the efficiency and the current. But based on our study, we also share that the theory resistance and also the other parameters matters on the module reliability. So that's why during the cell binning process, we can already identify that the unqualified cells. It means that maybe these cells are not so much percentage, maybe only like below like 0.5%, but this small number of cells, when they are in the module level, this can impact the whole panel's performance and reliability. So we are doing this kind of control at the beginning to mitigate the risk on the module level.
So that means if we buy cells from you, then we are sure that you are going to indicate all these parameters on the label, whether this can be used without any risk of hotspots or PID issues or corrosion issues. So this is all being taken care at your cell level.
Yeah, so it's like this. I mentioned that we are providing the cells to the most of the tier 1 module suppliers. So this means when you are buying the modules from the tier 1, probably you're also buying cells from SolarSpace. But when SolarSpace produce modules, we definitely only use our own cells. As I mentioned, our cell capacity is 50 gigawatts. It's much higher than our current 5 gigawatt module capacity.
Okay, thank you very much, Jeremy, for this very nice quality-oriented presentation. And if there are any questions in the chat window, so please stay online and answer these questions while enjoying our conference.
Sure. Thank you. Thank you, Jeremy.
Thank you.